Today we're going to continue with law of cosines, and you'll be doing some problems in your book where you have to solve the triangle using law of cosines. The two cases where we use law of cosines to start to solve a triangle are when we're given side angle side or side side side. So in this case, we're given that A is 3. I'm just going to draw a random triangle. A is 3, which means angle A is opposite the 3. C is 2, so angle C is opposite the 2. And B is 110 degrees, which means that this side is side B. This is a problem that we could not use law of sines on, because it would say sine of 110 over B equals sine of A over 3 equals sine of C over 2. There would be a variable in every one of those fractions. Instead, we're going to start with law of cosines. And the one thing you have to be careful of is when you do law of cosines, we usually write it initially as c squared equals a squared plus b squared minus 2ab cosine c. The issue is that these letters can change places. What we need to use is that this side C is opposite of this angle C in the triangle. So in this problem, the angle we know is the 110. That's angle B. The side that's opposite of that is side B. So we're going to write our equation as b squared equals, and then the other two sides, it doesn't matter whether I write 3 squared plus 2 squared or 2 squared plus 3 squared, minus 2 times 3 times 2 times cosine of 110. The only things that you would find using law of cosines would be this side or this angle that are opposite of each other. So then you would take this whole expression, put it into your calculator, and remember that's b squared, so don't forget to take the square root of that at the end, and we should get that b is 4.14. Now again, we can check a little bit that this is reasonable. 110 is an obtuse angle. That has to be the biggest angle in the triangle, so B has to be the longest side. Now, once you've found side B is 4.14, you have a choice. You can either find one of the angles using law of cosine, or you can switch to law of sine, as long as you're careful. You can switch to law of sines to find an angle after you found a side, as long as you know that that angle cannot be obtuse. In this case, since we have one angle that's 110 degrees, neither of these other angles can be obtuse, so law of sines is not an issue. We would have to check and make sure that it could not be obtuse, and I'll show you in the next problem how we would know that as well. So here, if I want to find angle A, for example, I would say sine of A over 3 equals sine of 110 over B, which is 4.14. And then I would solve this the way that we normally do, and A will end up being the inverse sine of 3 sine 110 divided by 4.14, it's a 4, and angle A ends up being 42.92 degrees. Now I have angle A and I have angle C, so I can subtract from 180. 180 minus 110 minus 42.92 will give me angle B, or angle C, which is 27.08 degrees. And we make sure that our triangle has 180 degrees total. So you have to use law of cosines as your first step, but once you have that side length, you can switch to law of sines, as long as you are careful that there's no way that the angle you're finding would be obtuse. So in this problem, this is our side-side case, side-side-side case, where you're given all three side lanes. So I have a triangle where A is 4, angle A is opposite of A, B is 3, angle B is opposite of B, C is 6, angle C is opposite of angle 6. I'm going to use law of cosines to start, because if I plugged into law of sines, all of the angles are unknown. There's no pair of opposite angle inside that I know both of. When I do this, I can set it up so that I can switch to law of sines afterward. The way I do that is to find the largest angle first. In this triangle, 6 is the largest side, so C has to be the largest angle. If I find the largest angle first, That is the only one that can be obtuse, and I don't have to worry about switching to law of sines. So I can start off by using 6 as my c. 6 squared equals 3 squared plus 4 squared minus 3 times 2 times 4 times 3 times cosine of angle C. Again, be careful when you solve this. You're going to subtract the 3 squared and the 4 squared first. Then you're going to divide both sides by -2 times 4 times 3. And use the fraction bar in your calculator if you can. I think most of you figured out what you needed to do yesterday. If you're having any calculation issues, let me know. This is all equal to cosine of C, so then you would take the inverse cosine of that, and you would get that angle C is 117.28 degrees. Once you have angle C, since that's the obtuse angle, you can find A or B using law of sines and then subtract from 180 to get the third angle. You would not want to use law of sines to get angle C because you would not get the correct answer. If you had found one of the other angles first and then switched to law of sines, you would get the supplement of this angle. Remember that when you hit the inverse sine button on your calculator, it always gives you an acute angle. Now that we do have the obtuse one, and really the simple rule is don't use law of sines to find the angle that's opposite of the largest side. Now that I have this at obtuse angle, I can find angle A by saying sine of 117.28 over 6 equals sine of A over 4. Solve that for angle A, and angle A should be 36.34 degrees. And then I subtract from 180 the two angles that I found to get that angle B is 26.38 degrees. One application problem here using law of cosines. Here we have a cruise ship that maintains an average speed of 15 knots and going from San Juan, Puerto Rico to Barbados, West Indies, a distance of 600 nautical miles. To avoid a tropical storm, the captain heads out of San Juan in a direction of 20 degrees off a direct heading to Barbados. The captain maintains the 15-knot speed for 10 hours, which means he'll have traveled 150 nautical miles. After which time the path to Barbados becomes clear of storms. There are two questions to answer here, and we're not actually going to answer them in the order they're asked. Through which angle should the captain turn to head directly to Barbados, and how long will it be before the ship reaches Barbados? So here we have the original distance is 600 nautical miles. He goes 20 degrees off that path for 150 nautical miles. We have side, angle, side in this triangle, which is a hint that we're going to use law of cosines. We need to find the angle through which he turns, which is the angle out here. So we're going to want to find this angle inside the triangle. If I call this A, I need to find the angle in the triangle and then take the supplement of that. And I need to find this length. I'll call that C. That's opposite of my 20 degrees. Now, the first question asks for the angle, but we're going to find C first because that's the only thing I can find in this triangle to start. So I'm going to start by finding C using law of cosines. So C squared equals 150 squared plus 600 squared minus 2 times 150 times 600 times cosine of 20 degrees. Type that all in my calculator, take the square root, and I get that C is about 461.90 miles. That's my distance. Then I want to find the measure of this angle A in the triangle. So I'm going to check and see if I can use law of sines. I cannot use law of sines to find A. I have two options. I can either use law of sines to find angle B, because A is opposite of the 600, so if any angle in this triangle is obtuse, it would be at A. So I either need to find angle B using law of sines, and then subtract from 180 to get angle A, or I can just use law of cosines to find angle A directly. This is cosine of A over here. So I have a couple options for finding that angle. When I do so, it should be about 153.63. Don't be surprised if, depending on whether you switch to law of sines or you stay with law of cosines, you get a slightly different answer. We're plugging a rounded value into each of these calculations, so depending on which one you use, it might be slightly off, just a couple hundredths. So I get 153.63. That's the angle inside the triangle. So now I can go back and answer the two questions. The first question says, through which angle should the captain turn? The angle the captain should turn is out here. So that's the supplement. 180 minus 153.63 is 26.37 degrees. How long will it be before the ship reaches Barbados? They have to travel 461.90 nautical miles, and they're going at 15 knots, which is 15 nautical miles per hour. So if I divide that length by 15, I get about 30.79 hours. And those are our two answers. There's one problem in the homework assignment that is similar to this. That's it for law of cosines, and let me know if you have any questions.